Good morning, friend. Today we're going to start digital electronics. Digital electronics, we're going to divide this in various groups. First of all, we will study about boolean algebra. Then logic gates. Then we will study about K-maps. Then combinational circuit. Then sequential circuit. And we will wind up with ADC and DAC converters. This is the syllabus for gate plus PSUs. Logic gates and additional there was logic family and memories. These two, logic family is excluded from gate and also there are very rare questions in PSUs. But if you go to IES, they have in the syllabus logic family, but questions are very rare. And memories, memories there might be some questions, but this memory will be covered in microprocessor. Okay. So let's start with the boolean algebra. Okay, friend, what is boolean algebra? These are simple calculation or simplification of algebraic expression, including minterms or max term simplification by using some laws, right? What are those laws and theorems? We will study in detail. Very useful in simplification of some expressions. What are those expressions? We call them expressions generally of variables less than equal to 3. If there are only 3 variables or less than 3 variables, then we can simplify it with the help of boolean algebra. Simplification can be done using boolean algebra, or maybe sometime if four variables are included. Variables, what are variables? Variables means input that you are taking, like A, B, C, D. When we will further go in this, we will understand the variables. So if variables are less than 3, you can easily use boolean algebra to simplify that expression. And simplified expression can be further used to construct a circuit, or using logic gates. We'll study the logic gate. So otherwise, if there is more than 3 variables, you are preferred to use K-map, because further K-maps will give you the most simplified equations. And boolean algebra is useful because using K-maps all the time become cumbersome, and hence we study boolean algebra to simplify the 3 variable circuits and all. Boolean algebra is basically followed with the help of some laws and some techniques which we're going to study. First of all, complement. Complement means if 1 is input, or any variable is 1, its complement will be 0. If 0, its complement will be 1. This is the property of NOT gate, which we will study. If you have not heard about the NOT gate, don't worry, we will study about the NOT gate. Why are you taking 1 and 0? We are taking 1 and 0 because in digital circuit, there are only 2 possibilities. Either you are going to switch on any circuit, or you're going to switch off that circuit. When you are going to switch it on, you can apply high voltage. That high voltage may be represented as 1. You can also represent it by 0 / 1 or 0, let us assume. And that low voltage or no voltage, if you don't apply any voltage, then we can represent it 0 or 1. There is only two possibilities. Therefore, in all the logic gates or in all the digital circuit, we are going to use 0, 1 and 0, 1 only. Okay, binary. So if A, how will you represent the complement of A? It's A complement. Okay, if any variable is B, its complement will be B complement. Sometimes it's may be written as A dash or B dash. Both are same. Okay. Then we have, this is the first, like we have the board mass rule in the algebra now. Similarly, like multiplication, addition, this is also a technique or a tool, complement. Then we have AND operation. 1 AND with 0 will give you 0, you know this. Just for a quick recap. Give you 0, right? Or you can say that anything multiplied with 0 is 0. 0, 0. So AND operation, anything, if 0 is AND with 1, the output will always be 0. If any one of the input is 0, output is 0, right? And if both the input are 1, then the output is 1. This is AND operation, just remember. Therefore, we have A dot A is equal to A. And if we are going to write in the resemblance of this, we can write A dot A bar equal to 0, A dot A equal to A bar dot A equal to 0, which is nothing but the same. And again, A bar dot with 0 is 0. And we have A dot with 0 equal to 0, right? All the possibilities has been covered. If A and A bar is there, output will be 0. If both are A, output will be A. A dot A is A. A dot A is A. Here A is 1. Both are A. A dot A 1. Here A is 0. A dot A is A. A and A bar 0 output. A and A bar output is 0. A and A bar output is 0. These two cases is represented by this. And these two cases, A dot A is represented by this equation. And these two are the same. A dot A bar is equal to 0 or A bar dot A equal to 0. This property is known as the commutative property, in which we will study when we study about the gates. And anything, either you AND A bar with 0, output will be 0, or A with 0, output will be 0. So if we have some expression like we have A, B plus A bar A plus B bar B plus B bar A. So if this is a logical expression, so when you use your boolean algebra to simplify this, you will straight away make this 0, right? A bar dot A is 0, B bar dot B is 0. If A bar A dot is 0, in place of A variable, if you use B variable, B bar B is also 0. This we get from the AND property, okay? So if this is a logical expression, this will simplify to A bar AB bar plus 0 plus B bar A, right? If from here we take A common, we get A B plus B bar plus 0 plus 0. This is the final expression until now. Okay. Now we have read about the complement, then we have read about the AND operation. Now let's study about the OR operation. OR, we have 0, if you add with 0 is 0, 1 add with 1 is 0. Both this can be written as A plus A, that is A. We have 0 add with 1 is equal to 1. We have 1 add with 0, again the answer is 1. Both this can be represented as A plus A bar, option is A. Okay, sorry, it's 1. A plus A bar is 1. And further, you have seen that if any one of the, just 1, I'm sorry. If any one of the input is 1, here 1, here is 1, here is 1, output is 1 in OR operation, right? In OR operation, if any one of the input is 1, output is 1. In AND operation, if any one of the input is 0, output is 0. Hence, we can write A plus 1 is 1, A bar plus 1 is 1. If any one of the input is 1, then output will be 1. Output will be 1. Okay, understand? So if we apply the above OR operation over here, we have B plus B bar, that will be equal to 1, so A dot 1, and we know that anything multiplied with 1 is 1 itself, plus 0 is nothing but 0. So this will become A plus 0, and we know that A plus 0 is what? A plus 0 is A itself. Addition of A with 0 is A, right? However, if it had been like A plus 1, then output would be 1. Clear? So the entire logical expression will get simplified to A like this. If you want to implement this through a logic circuit, what you need to do is just take an input A and let it be the output also. You don't need to apply any logic gates. Output is A only, right? So this was the 3 operations which was used which will be very helpful in Boolean solving the logical expression using Boolean algebra, complement and an OR, and I have written the properties for you people. And then there are certain theorems. What are those theorems? Those theorems basically help you to simplify the things in a very short period of time, which may be done by using further some techniques. But like if you know that the maximum power transfer theorem, you know that if there is maximum power to be transferred, load must be equal to the source resistance. Load resistance must be equal to the source resistance. So this is a theorem which you can directly apply, right? You can also derive the same, but you don't go for the derivation, you directly apply the theorem because you are always interested in the result in the in solving questions, because there are MCQ type questions, so you are interested in getting the result, right? So there are certain theorems. First of all, we have A plus B into A plus C. This is the Boolean expression. If you simplify it, you will finally get A plus BC. Okay, so this theorem is known as transposition theorem. However, the name is not so important, but even though in some PSUs sometimes questions comes directly, what is transposition theorem? 4 options are given and you have to take A plus B into A plus C is A plus BC. This I'll let you know how you can get this from this. But the final thing is that when you ever see this expression, you can directly substitute with this expression. Or if you see this expression and according to the situation, you can accordingly substitute it back, right? So let expand this A plus B into A plus C. I don't know anything, so I have only one option over here. Let's expand it. A dot A plus AC plus AB plus BC, right? So if I take A common, right, from here, what I'll get? I get A common, then I'll have A dot A is what? A itself, right? We're using AND property. A dot A is A. So this is A. If I take A common, this will remain once, plus C plus B plus BC, and I said if any one of the input is 1, and this all are OR operation, plus and plus, so this whole bracket will give us what? 1. So A dot with 1 plus BC, and this is nothing but A plus BC. So in order to avoid these 2 steps, you can directly substitute A plus B into A plus C is A plus BC. This is called transposition theorem. Second is distribution theorem, which is the reverse of this. Distribution, I think the writing is clear to you. Distribution theorem, D-I-S-T-R-I-B-U-T-I-O-N, distribution theorem, right? The reverse of this, A plus BC can also be written as A plus B into A plus C. This you can easily substitute according to the question's demand, what expressions you need. Okay. regarding question practice, since this video would not take would become too long if I start discussing questions over here, so I will make a separate video for question discussion and explanation each of this theorem in detail. First, let's go cover the theory part in short, right? Because theory part is just important to understand the technique and then what it's all take about to solve the questions. This all thing will come again and again if I start explaining the question. So if you don't understand, don't worry. Just have a view of all this theory, and they will come back to all this theory when we start discussing the questions, right? So we have transposition theorem. We have done a plus bc into a plus c is a plus bc, right? What you have to do, you have to see what is repeated and then multiply this thing. For example, if we have x bar plus z into x bar plus b, so this will lead us to this. X bar is repeated, x bar plus b z. You will need to practice. You will solve more questions. You will understand how to shorten it and how to elongate it. This a plus b c is a plus b into a plus c. This is distribution theorem, right? So now there is a very important theorem, redundancy. If I commit a mistake in writing this spelling, forgive me. Thing is that you must understand this term, redundancy theorem, right? What is redundancy theorem? This is very important, and I'll tell you the technique how you can identify what is a redundancy theorem. Suppose we have three terms, mostly applicable to three variables: a plus b, so ab plus suppose bc bar plus ac bar, or not c bar. Let's take this. If you have seen such type of expression, or you will easily understand whether redundancy theorem is applicable to this or not. You will understand yourself after I complete with this. Let's take another example: a plus b bar into a plus c into b plus c. Let's take some more example: a bar b bar plus b bar c plus a bar c bar. Let's take another one: a bar plus b bar, b bar plus c bar, and a bar plus c. Right? See, in all the example I have taken, I have used three variables a, b, and c, and in all the examples you will see that there are all the possible terms: a, b, b, c, a, c, a, b, b, c, a, c, a, b, b, c, and a, c, a, b, b, c, and a, c, a, b, b, c, and a, c. Right? So it follows certain pattern. If this pattern is followed, now you have to check only one thing, that which term is the redundancy term in these expressions. So you see that here c is showing some variations. Here c term is showing some variation. We have c bar and we have c. Okay, so this term is mandatory because it is going into some changes. So what is the redundancy term? Except these two terms, this is the redundancy term. So this can be written as ac plus bc bar. Right? Similarly, here you see b and b bar. These two terms are undergoing some variations. So apart from this term is a redundancy term. A b bar plus bc is the final output. And here we see that a plus b bar and again b bar, and here is b. So these two terms are undergoing variations. So this is a redundancy. So a b bar and b plus is the output. Here also this is bar c. C is here, we can see that c is going into variations. So these two terms are taken into consideration, and this is a redundancy term: b bar c plus a bar c bar. Finally, here we have bar on all except c is going variations. So these two terms will be considered, and this is redundancy, right? So this was very easy. You have to understand the redundancy theorem. And first you understand, you have to check out there must be three variables, and there must be all the possibilities: ab plus bc plus ca, or ab, all are occurring two times. Each variables are coming twice, and then there is some variations in any two of them. The another one is the redundancy. So this was redundancy theorem, transposition theorem, and distribution theorem. Now we will come to some advanced form of where we can implement this boolean algebra. So let's start. First of all, we have a sum of product, SOP form. Okay, this is called sum of product. You must have heard about these terms. sum of product. Then we have, okay, let's discuss sum of product first. In sum of product, what we do, we have sum of what product, and there will be a product of terms which ABC plus A bar plus AC. These are product, ABC are product, and then we are taking sum of this, right? So what we can say that this is what we are doing, we are ANDing and then we are ORing, yani ki and OR. We have to AND first, AND gate, and all the things, and all the things, AND gate. When you study gate, we will learn how we do this. And then the output of all the AND gate, if we give here 3 input A, B, C, here also A bar, B bar, and A bar, B and C. So we get the output as A, B, C and A bar, B, C, and then what we have to do, we have to give it to the OR gate, to AND OR operation. Okay? But also 2 important points here is, one is represented as A or B or C or any variable, and 0 is represented as its complement, A bar, B bar, C bar, right? So if we have an A, B, C, we understand that this is one expression, plus A bar, B, C is clearly 0, 1 expression, and AC is clearly 1 and 1. Okay, A is 1, C is 1 over here. Another point is important, okay, that there are 2 forms, canonical and minimal. What is minimal? Minimal, as its term suggests, that is reduced number of terms. Right? Canonical means full expression. Full expression, right? If we have suppose you have AB plus BC. Full expression means all variable must be included. All variable, right? If we have AB and BC, this is a minimal term, because we can see that A, B and C, there are 3 variables, but each expression or each term in an expression is only composed of 2 variables. So this is already minimized or simplified term. So to convert it to the minimal, what you can do, this is just an example. I will deal with all this theoretical aspect in questions in next video. So just to cover all the theoretical parts in one video, and then I will cover with all the multiple questions in the next video, right? So AB, we know that if we multiply it with 1, it remains the same. BC multiplied 1 remains the same. And further, we also know by the previous theorems and the techniques that if we add A plus A bar, the result is 1 only. So this one can be written as A plus A bar, or it can be written as B plus B bar, or it can be written as C plus C bar. Everything is equivalent to 1, right? So here we have A and B. What is missing in this term to converting, if we want to convert it into the canonical expression, there is a C, expression C is missing, right? So we will multiply this expression with C plus C bar. Why we are multiplying it C plus C bar? Because C plus C bar exactly means to 1, and if we multiply this expression to 1, it remains the same. Similarly, here A is missing, so we multiply with A plus A bar, right? Now, just you need to open the bracket, ABC plus ABC bar plus ABC again and A bar BC. Okay, this is BC, which can be written as ABC, commutative property, which I'll deal when I talk about the gates. And we have seen that ABC plus ABC, what we have about from the previous discussion, we know that A plus A is A. So if A plus ABC plus ABC is ABC itself plus A BC bar plus A bar BC. This is the canonical form, and this is AB plus BC is minimal form. This is minimal and this is canonical. Okay. So now we have sum of product, we have done with sum of product. Now there is another technique which is called product of sum, POS. Product of sum. What is this product of sum? We have product of sum, okay? So let's make sum and then we have to do with product. Product of sum. So we'll do the product, but we will first need to have the sum. A plus B plus C bar, and A plus C bar. Suppose these are the sum, then we need to product it. So this type of expression is known as the product of sum. We have a product of what? Sum. These are sum, and then we have a product of this. So again, here we have a canonical and minimal. The definition remains the same. I will show you how you can convert it to a canonical form. And minimal form is just you need to simplify. If you simplify this equation further, it will get back to this equation only. So here, important point is that 1 is equivalent to bar, A bar, comma B bar, comma C bar, and 0 is equivalent to A, comma B, comma C. Either it can be represented as A or B or C, just reverse of the SOP. So A plus B can be written as, what I say, A can be written as 0, A is 0 plus 0. A plus B plus C can be written as, that means this term is nothing but, we have added it 0, actually it's not written such 0 0, it's just represent that A is 0, B is 0 and C bar is 1. Then again A plus C bar means A is 0 and B, we don't know anything about B, so we leave a don't care over there. This is a don't care, I don't care about the B. And then we have a C bar means 1. Right. Similarly, you can also represent as A is 0, B is 0, and C we don't care about C. So in canonical form, we're going to convert it in canonical and minimal form. But you have to keep in mind that 1 is a representation of the complement of A or complement of B or complement of C, right? And 0 is a representation of A, B, C. Whereas in the sum of product, 1 is just A, B, C and 0 is its complement, which is a general trend, right? But in product of sum, this is a general. General, we take 1 as A, B, C and complement 0 as A bar, B bar and C bar. So this is product of sum is the just opposite of this, and you have to keep this in mind. Let you understand why this 0 0 0 is 1 1 1 is helpful. Okay, so let's start. We have an A plus B bar and we have A bar plus B bar. This is a simple example just to save time. I'll discuss with you some important questions in all the topics I have been covering. So this is a minimal form. Why this is a minimal form? Let's say we have C bar. Okay. Now we can judge easily that this is a minimal form because we have again 3 variables A, B, C, but each term is having only 2 variables. So what we can do now? This is A plus B bar, and we know that if we add anything, the output remains the what? This is A plus B bar. If we add it over 1, what will this term become? This term will become 1. So it's going to change. If we add it as 0, what will this term going to change? It will remain the same. A plus B bar is the output. So what we can do is A plus B bar plus, we can add 0 over here. And then we have A bar plus C bar, we can add 0 over here. So what we can do, we can easily, let me first make the camera start. Okay, so what we can do, we can easily represent 0 with A bar or B bar or C bar, right? All these things 0, we have read about the OR AND operation. But we need to replace it with A, C bar. Why? We already know that C bar expression is missing, and what is the canonical? Which it should have all the variables. So replacing 0 with C bar and replacing 0 with B bar. Now we know that if we consider this term as X, so X plus C bar, what can be written? It's with the help of distribution theorem. It can be written as X plus C into X plus C bar. And if this term is Y, then we can write this term as Y plus B into Y plus B bar. By applying transposition theorem, we will get the same. Y plus, Y is repeating, Y in plus B bar, right? Now replace it, you will get your A plus B bar plus C and A plus A plus B bar plus C bar and A bar plus C bar plus B and A bar plus C bar plus B bar. So this is these canonical expressions. Okay. Now to make a quick revision, okay, let's wind it up. Now I also told you that why this is 1010 funda. Sum of product, we represent 1 as a comma b comma c, 0 as a comma bar b bar c bar. It is first and then or. First you have to AND the term and then you have to add the term, the AND or operation. And then I told about the canonical form and that form. And each expression like a b c plus b c plus a bar b, this each expression is known as min term over here. Okay, min terms. So here how many min terms are there? Only 3. And on the other hand, in product of sum, you have just the reverse. A means a bar or b bar or c bar, and 0 means a b c, and this is OR AND operation, and expression can be written as a b c into b plus c into a bar plus b, and each term like this term and this term are known as max term. So here also 3 max term. Okay. Now why I told that you can easily replace a b c and with 0 0 or 1 1 0, because suppose if this term is written as a b c plus b c plus a bar b. So first of all what you need to do is to convert into the canonical form, because you need to convert into canonical form, then it is easy for you. However, I will let you know how you can do it the same without converting into the canonical form. So first let's convert this into the canonical form, and then we use the same expression in order to save time, right, for POS. So this is easy. Let's convert this into the canonical form. ABC plus a bar BC, again ABC, and then we have a bar BC plus a bar BC bar, right? So we have two ABC. One is a redundancy over here. We have a bar BC. Again, this is a redundancy. So what we are left with, ABC plus a bar BC plus a bar BC bar, right? So now what you're gonna do is you're gonna replace this ABC with 101, and we're gonna check it out what this term are going to be. This is 111. Okay, this term is 0, 011. Okay, this term is 010, right? 0, a bar 0, since this is the min terms. So this represents decimal 7. This represents decimal, although you might be knowing or might not be knowing. But by the time when I come to the code conversion and number system, then you will easily come to understand. But anyhow, if you know, it's good. If you don't know, just pass by the video and you will come to understand that this is 7 equivalent and this is 3 equivalent and this is 2 equivalent. 7 3 2. So we can say in short that this expression was the sum. This is sigma, sum of product of 7, 3, 2, right? 7, 3, 2. Similarly, therefore, if we have an expression like we have say function f is summation of 7, 3, 2, we will use the k-map, or we can directly write this ABC, and for this we can write 7 means A, B, C, 3 means A bar since A 0, B, C, and 2 means A bar, B, C bar. We can directly convert into this expression, and with this expression or this expressions means the same. Both are equivalent. Both means the same. Similarly, you can also convert this A bar, B bar, A plus B bar into A plus C, this one, into its canonical form. We have expanded into the canonical form, and we can then write this 0, 1, 0, 0, 1, 0, and so this term is represented at what this term is. This term is 2. So it is 0, 1, 1. It's again 3. It's 1, 1, 0. That means it is what? It is 6, right? And it is 1, 1, 1. It's 7. So this expression can be written as, it means 5. I means product of 2, 3, 6, 7. All the terms. When we study further, we will know that these two terms are the complement of each other. Either you write the product of 2, 3, 6, 7, or you write the complement product of 2, 3, 6, 7, it will lead us to min terms addition. That will come discuss in detail when we talk about the questions. When we'll deal about the questions, we will discuss all the things. But just in order to have a very basic idea about the theoretical aspect, I'm going to tell you all these things in very short, such that you have just an idea when I deal with the questions, so you will not be shocked that this is a new term for you. So this is the product of 2, 3, 6, 7, right? So if we have a function which is given as a product of 2, 3, 6, 7, first of all, it means that this is nothing but it is product of sum, and this 2, 3, 6, 7 will be written accordingly, right? You write the expression of 2, and then according to the 0 you have A, B or C. You have like A, B or C, you put it like this, and then if you have to write 2, since 2 means 0, 1, 0, so this expression will mean nothing but A, B bar and C in max term, and A bar, B and C bar in min terms. I repeat, for this, if you want to write the max term expression, so it will be A plus B bar plus C, this term, A plus B bar plus C. And if you're going to write a min term expression, it will be A bar, B, C bar. That's simple, very simple. Okay, these things will become more clear when we'll deal with lots of questions. So if you don't understand, do not worry, you will understand all the things. So what we have dealt with the min terms, and we have dealt with the max term, we have dealt with the canonical and minimal terms. Now let's write the dual. What is this dual term? What is this dual? Dual term may be just what you need to do is convert the AND expression to OR expression. For example, if we have A, B, C plus B, C, A bar plus A bar, B, C bar. This, if you have to write the dual of this expression, what you need to do is just convert AND to OR, nothing else. A plus B plus C, B plus C plus A bar plus B plus C bar. Okay, this is the dual. Complement expression, then we have a complement expression, and truth table and Venn diagram, and then switching circuit. All these things we'll discuss when we discuss. For the time being, you just remember the complement using De Morgan law. Complement expression, not any variable. Complement of A is A bar. What is the complement of an expression? ABC plus BC. What is the complement of this? Complement entire this. So to deal with, we have De Morgan's law, which says A plus B plus C or D plus E, anything, expression complement will be A bar, B bar into C bar. Similarly, ABC complement is A bar plus B bar plus C bar. So it is dual plus complement of each term. ABC we converting into AND, but with a complement of each term. Again, ABC product we converting into the OR product, A plus B plus C with a complement of each term. So it is a both. We are doing it dual and with the complement of each term, right? So this is the De Morgan law. Then we have a positive logic and negative logic. Okay, so there's lots of theory to discuss, but I think that all the theories is not necessary. Only the techniques which are used in solving the questions are necessary. So I'll not be dealing with all the theories. However, if there is some questions which comes, then definitely I will be telling you all the theories and then related to that questions. In this way, you will be able to know that different types of questions, how it comes, and then you will be able to solve those questions also. Okay. So then we have a truth table. What is the truth table? I'll explain when I will deal with the gates and Venn diagram, switching circuit, all this statement circuit, all this will come up when we start solving the questions. So let's start the general discussions for suppose we have an n variable, or suppose we have a two variable. Two variable means A and B. What are the different expressions possible for two variables? So let's start with the possible values. This is the technique of writing the possible values. Okay, this is called the least significant bit, which is continuously changing, 10 10 10. This is called the most significant bit. All this will come. If you don't understand, don't worry at all. So these are the different expressions: 0 0 0 1 1 0 1 1. And then if you want to convert it into the sum of product or product of sum, just write a bar b bar plus this is a bar b bar, this is a bar b, this is a b bar, and this is a b, right? For product of sum, this is a plus b, this is a plus b bar, this is a bar plus b, and this is a bar plus b bar, right? For two variables, we have only four possible terms that can be written as 2 raised to the power 2. Similarly, for n variable, total number of min terms or max term possible is min terms slash max term possible is 2 raised to the power n for n variable, right? So if there are three variable, total number of min terms will or max term will be 2 raised to the power 3, that is equal to 8 terms, right? If there are four variables, then total number of max term or total number of min terms will be equal to 2 raised to the power 4. That means 16 total possible terms, right? Now, what are the total number of logical expression? Logical expression, what do you mean by the logical expressions? For example, if we have suppose only two terms a and b, so what are the possible logical expressions? Not min terms, logical expressions. A bar, b bar, right? Then we have a bar, b, all this, okay? All such type of any possible expressions with a and a bar and b bar, a b bar, and all those terms, including 0, including 1, including or expressions, including min terms and max terms, all those possible things. Okay, so let's start with these two terms and we'll generalize for the entire n variables. For a and b, there are two variables. So what are the possible terms? We have a bar, b bar. Then we have 4 min terms possible, and we have 4 max term possible, right? Then we have 0. Then we have 1. Then we have 2 additional terms, that is XOR term and XNOR term. XOR and XNOR may be new words for you, might not be. So a b bar plus a bar b plus b a bar, and a bar b bar plus a b. These two terms. This is called XOR. This is called XNOR. We'll come to know about this. This expression is called XOR expression. This expression is called XNOR expression, and these all expressions are called max term expression. These all expressions are called min term expression. So we have complement expression of a and b, 2. We have min term expression of a and b. We have max term expression of a and b, and you get 2 complement expression for one variable, 2 complement expression for another variable. Then we have 2 XOR and XNOR combination, plus we have 0 1 additional 2, plus we have 4 min terms and 4 max terms. These all 4, 8, 12, 16 terms. That means if there are 2 variables, then total number of logical expression is 16. This can be written as 2, that can be written as 4 square, or it can be written as 2 square cos square. That is, for n variable, we have total number of possible logical expression is equal to 2 raised to the power n raised to the power n. Okay, let's analyze this. No, it won't be. So it will be like if 3, then it will be 2 raised to the power 2 raised to the power n, or you can simply write that 4 raised to the power n, not an issue. So if there is n variable, total number of min terms and max term is 2 raised to the power n. If there is n variable, this is min term or max term. If there are n variable, total number of the expression, logical expression, is 4 raised to the power n. And for your convenience, I am telling you that telling this also. For n variable, there will be 2 raised to the power n minus number of duals, I am talking about the number of duals, there will be 2 raised to the power 2 into n minus 1 or 4 raised to the power n minus 1. This is number of duals. Okay. That's all from my side from this Boolean algebra, and I've discussed with almost all the theoretical parts in this Boolean algebra. So these are the important notes which you might need to make a revision notes of all this. So a quick recap